All right, so that was Docker Compose. This is much more, what I'm going to say it's probably more useful to on your day-to-day basis, and it's much more oriented towards development and kind of experiences and CI/CD kind of experiences. Kubernetes is very much oriented towards production workloads. Like Kubernetes was written for production workloads. You probably don't typically want to run Kubernetes on your computer for just a slew of reasons that we'll talk about. So Kubernetes. This section, I'm just going to tell you like kind of the high-level concepts of Kubernetes, and then I'm going to show you kind of a cheat way to get introduced to Kubernetes. So first of all, you'll likely see Kubernetes often abbreviated as KATES, K8S, because there's 8 characters between K and S. That's where that comes from. People are lazy and can't remember how to spell it. Like especially for non-English speakers, it can be difficult to remember how to spell Kubernetes. So that's why it's often abbreviated that way. So Kubernetes, I like to tell people that I think containers are simple and more easy, and everyone should know how to use containers and Docker and things like that. Kubernetes is hard and it's difficult, and not everyone should know how to use Kubernetes. But I'm going to show you how to do it just so you understand what it is, and so you can know when to reach for it and when you definitely do not want to reach for it. Like for me personally, I compare this to Redux in React, right? Redux, it's really difficult and not always necessary, and people still want to know it. So I'm going to teach you how to use Redux, and I'm going to tell you not to use it for the most part. And that's kind of my point here with Kubernetes as well, is that it's difficult, it's hard, it's a complicated product that solves a complicated problem. And for the most part, you don't normally need it unless you are a big company that's shipping big microservice-oriented architecture. This was created at Google for Google problems, and most of us don't necessarily have Google problems on the day-to-day. Okay, so let's talk about when you would want to use it. Kubernetes is useful if you have a lot of containers, a lot of different kind of services, right? Like we have the web service, the DB service, and you have all these various different services, and they have complex relationships between each other. That's when Kubernetes is very, very useful, because you can define these relationships, you can define the security rules, it scales out very well. That's another thing that Kubernetes is very good at doing. It's very good at taking one container and making that 100 containers and then going back down to one container, right? It's very, very good at checking the health of your containers. So if you have like 40 containers and one of them starts like, going wonky or something like that, it can detect that via health checks and say, cool, bad container, shut that one down, spin one up, put it back in its place. So it's really good at stuff like that. These are all very, very production-oriented kind of problems, right? So let's go over some of the fundamental concepts and terminology of Kubernetes, because you kind of have to understand these to be able to use Kubernetes. So when you spin up a Kubernetes cluster of any variety, the first thing is it's going to have a master. And that's kind of like a central control pod that controls everything else in the service. So a lot of cloud providers won't charge you for the master. So I know Azure and Google Cloud Platform don't charge you for the master, but Amazon does actually. So they will actually charge you for the nodes that it's running inside of Kubernetes to control everything else. That's for AKS, which is Azure Kubernetes Service, and GKE, Google's Kubernetes Engine, but Elastic Kubernetes Service, which is the Amazon one, does charge you for the master. You can also run Kubernetes without using like AKS or GKE or anything like that, just on VMs yourself and run your own stuff. It's just hard, right? Because you have to now manage not only all the various different pods and nodes and things like that, you also have to manage the hosts, which is more work. But a bunch of companies do it. Okay. So that's what the master is. It's like the central control plane. Like when you tell Kubernetes, hey, scale this up, to 10 nodes, you're going to talk to the master, and then the master is going to go do all the work for you. So it's like the brain. I think that's a good analogy. It's the brain of the Kubernetes cluster. Okay, the next thing that you need to know about is nodes, which is not to be confused with Node.js. There's no relation between the two. These are actually like the worker endpoints, the nodes that are actually going to be doing the work for you, and they're the ones that actually talk to master. So one node can contain multiple containers, right? Just like a VM can have multiple containers running on it, but it's like these kind of endpoints that are managing all these kind of workloads for you. Some of your nodes will just be one container as well. And that's also can be normal as well, particularly if you have either small nodes or you have containers that take a lot of resources. So like if you're running a Node.js server like we are, you'll likely have many containers on one node. That is kind of frequently what will happen. So technically a node is just like a deploy target. It can be a VM, it could be another container, it could be a little bare metal server. It's relatively unimportant of what the node is as long as it can accept containers. Okay? So at that point, then we have things that are called pods, and it's basically a deployment unit that cannot be separated. So I'm trying to think of a good example of that. Let's say you had this microservice that talked to this microservice, and they're just strongly linked together. Maybe it's like a password service and a user service, and they can't really be separated, and so they need to be deployed together. That would be considered a pod, right? So it'd be like 2 or 3 containers that they're atomic, right? They can't be split apart, so you deploy them as one pod. That's not always the case. A lot of times your pods will just be one container, like it'll just be one service that you're running, but frequently it can also be, multiple things together. And then you'll have this pod that talks to this pod, and all those pods talking together will make up like a service. At the end of that, you'll have like a user service that people will talk to. So let's talk about what a service is. When you have pods and when you have these containers, they will be talking to each other, and those kind of routing things will be dynamic because you'll be spinning up pods and destroying pods, and then like you'll be doing all sorts of different things. And at any given time, you don't actually know how many containers you'll be running at any given time. So that's when services become useful, because services are like a group of pods together that make up one service. So you'll have like let's say like a checkout service. And then you can have your cart service talk to the checkout service, and they talk to each other on these one URLs. And they are consistent, despite the fact that these services are totally separate from each other. They can talk to each other in a consistent way, and you define those as a service. Does that kind of make sense? We're getting to the point where like there's just a lot of stuff coming at you. I'm trying to teach you Kubernetes, which again, there should be like a 5-day course just on Kubernetes in like a half hour. So it's complicated. If you feel like it's complicated, it's because it's complicated, right? So just be aware of that. Okay, and then at the end of that, you have what's called a deployment, which is what you describe to Kubernetes. Here's the things that I would like to go out. And then you can have multiple different deployments. You can roll back deployments. It's kind of like a delta between, or like a change set of, I had this, and now I want to go here, right? So you're defining like something that's different. And if that deployment goes wrong, you can say, hey, roll that change set back to where it was before because it broke, right? And then you can deploy more deployments as well. So you're kind of defining differences over time in your cluster.